All right, we're 2 minutes past our scheduled start time, and so let's get started. Hello, everyone. My name is Nick Swami, and it's my pleasure to welcome you to the spring edition of the Developing Secure Systems Summit. It's great to see you all here. Today, we have a great panel of speakers from the US government sharing their perspectives on developing secure systems. But before that, let me just make a few introductory remarks. First, DS3 is organized by a diverse steering committee sponsored by Microsoft Research and Microsoft Azure Sphere, and I want to extend my thanks to them. I also want to thank especially the MSR Media support team who produced the event and handled a lot of the logistics. This couldn't happen without them, so special thanks to them. We have a great schedule of speakers lined up in the next few months. We meet roughly every other Wednesday at various times to accommodate speaker schedules, usually at around 9 a.m. Pacific, but do check out our website for the schedule each week. I'm really excited about all our speakers, and I hope you'll join our future meetings too and help spread the word. This meeting is being recorded and streamed simultaneously to a public YouTube feed, so heads up, by participating here, you are consenting to share any content, particularly your audio, to a public stream. You are muted by default, but I encourage you to ask questions. You can do that both on Teams and on YouTube by typing your question into the chat. If you want to speak on Teams, please use the raise your hand feature and we'll give you permission to unmute yourself and then you can unmute. Let me just emphasize that. We cannot unmute you. We give you permission to unmute and then you can unmute yourself. Okay, with that, let's get to the main event of the day. I'm happy to introduce our moderator for our panel, Brad Martin from the National Security Agency's Laboratory for Advanced Cybersecurity Research. Brad has a strong history of working on, facilitating, and promoting the adoption of high-assurance computer systems in many parts of the US government. He serves as the co-chair of the Networking and Information Technology Research and Development Program's Computing-Enabled Network Physical Systems Interagency Working Group, and he's also on the steering committee of DS3. Thank you for chairing today's session, Brad. It's all yours.
Okay, great. Thank you, Nick. Thanks for the invite. And again, really appreciate everyone for tuning in live. And again, look forward to sort of also those will be able to join through the YouTube venue. And so for today, really the focus is on looking at sort of U.S. government perspectives on developing secure systems, challenges and opportunities. I believe you heard today from our panelists perspectives on what it means to develop secure systems, their thoughts on where they see the hardest challenges for designing in and building in security, and where they believe they can realize the greatest near-term successes and benefits for their customers and stakeholders. And so with that, we'll start off with our first panelist, Neal Ziring. I'll just give you a little background on Neal. Many of you are probably familiar with him, but Neal is currently serving as the Technical Director for the National Security Agency's Cybersecurity Directorate. Over his long history there, he served in a number of technical director positions within our Capabilities Directorate as well as our Information Assurance Directorate. He has personal expertise areas that include security automation, cloud computing, data access control, and cyber defense. And prior to coming to NSA, he worked at AT&T Bell Labs. And so with that, Neal, I'll turn things over to you for your opening remarks.
Okay, thanks, Brad. I hope my audio and video are coming in okay. And so I have a few opening remarks, and I'll try not to take so long so that we can spend more time on the Q&A, which I'm sure will be really exciting. So I'd like to start out, and I'm going to stay a little high level because I'm getting to go first, to think about security or assurance of a software system as an aggregated property. And that affects how we have to build it in to our systems. All right. Modern software systems, especially the ones that we're creating within the various parts of the Department of Defense, other parts of government, the intelligence community, they're all composite systems, right? They use multiple languages and frameworks. They're spread across on-prem and cloud. They run in embedded systems. They have to run different operating systems at different levels. And by trying to gain security, in other words, the assurance that these systems will exhibit certain behaviors and positively not exhibit other behaviors, is something that has to be built up from the individual components up through subsystems and eventually to the entire system, so that it will be a system that will exhibit those properties and that other systems can rely upon to exhibit those security properties. And further, that consideration of the security attributes or guarantees that we want to get out of a system has to extend across the whole system lifecycle, right? It's not only during coding or not only during operation of the system. It's all the pieces. Okay, and so every component does not necessarily have to exhibit or provide all the security features. That would be tremendously expensive and probably overkill in most cases. So if you have, let's say, a sophisticated, say, management system for managing some weapons platform, right? There are going to be buried components that have specific jobs. They're not doing the authentication function or the cryptographic functions. They're just doing their little function. And eventually you have to compose all those functions up into a set of overall system guarantees or meeting system requirements. And to my mind, that's one of the biggest, if not the biggest challenge we face in developing secure systems today. It's not, although it's hard enough to develop an individual component that reliably and with assurance provides certain features, but then composing them to guarantee overall system features, I think, is even harder or much more difficult. So when we think about the life cycle, this has always been a big thing within government and especially the Department of Defense, but events of the last few months have raised people's awareness of this issue even higher. And of course, it applies to both hardware and software, but we're focusing on software here today. The fact that in the recent set of attacks with SolarWinds, that a very popular commercial product was subjected to basically a malware injection into its update build process, has opened folks' eyes to the fact that you can't simply write good code. You have to assure that the whole path from what it was that you intended to write to what actually runs on the end system, you need assurance through that entire sort of pipeline or chain. And then for some sensitive systems, those assurances can even extend into the decommissioning or retirement of that system. And that's something I have not seen as much of in industry, sort of attention to how you can securely shut down and decommission a system. Okay, how am I doing in time? Okay. Yeah, I'll get back to that later. Another challenge that I'd like to talk about very briefly is thinking about dependencies, right? When we're building these complex composite systems, some of the components we write in our own organizations, and a lot of the components we're accepting from other parties, whether they're open source components that we retrieve from some open source repo and compile into our systems, or maybe they're cloud services that the cloud provider or their partners offers to us, or their services provided by another system within the environment. You think about the complex environment of a Navy warship. Every system on that ship depends on other systems on the ship and ashore. Developers, an individual developer doesn't control very much of that. And then how do we, the developers, the system integrators, how can they gain greater visibility and adjust their actions to produce a better, more secure end result? Okay, and there are multiple ways that can happen, but I think it's an area where, as I'll talk more about in the Q&A, that we may have gaps today, or that we need additional research or additional tooling or better processes to help that. and then extending out through the life cycle. Just because you used a component during the development of a system and it was good then, doesn't mean it's going to stay good. New vulnerabilities are discovered. New versions of systems come out that may have new features or missing old features. Tracking that aspect over the lifetime of a system, especially a system in the DoD, which oftentimes must be in service for many years or even decades, can be extremely challenging. So later on during the Q&A, I'll talk about gaps that I think I see in the more of the design stage of our software life cycles, in the actual development stages, where there's been a lot of attention in recent years, and also in testing and build and distribution. I think all of those parts of our life cycle have specific issues that need our attention, but also have opportunities where we can apply some research, apply some tooling, and actually make a significant difference to the assurance that we can offer the ultimate end users of these systems that we build. So that's it for my sort of opening remarks, and have a whole bunch of topics here that I hope to hit during the Q&A. Back to you, Brad.
Okay, great. Thank you, Neal, for your opening remarks. Okay. We'll move to our next panelist, Colonel Brian Beachkofski. Colonel Brian Beachkofski is the commander, AFLCMC Detachment 12, Kessel Run. Kessel Run is the Air Force premier agile software development organization responsible for introducing commercial software development tools, methods, and culture into the Air Force. Brian's most recent reserve assignment before becoming the Detachment 12 commander was as the senior IMA Air Force Scientific Advisory Board at the Pentagon. In his role, he supported studies and research plans conducted by the Scientific Advisory Board for the Secretary and the Chief of Staff of the Air Force, informing investment decisions to ensure future technical dominance for the United States. In 2009, Brian was named the Outstanding Senior Civilian Analyst of the Year for the United States Air Force. So with that, I'll turn it over to you, Brian, for your initial comments.
Thank you so much. Yeah, I'd love to make some initial comments and maybe build on a couple of things that Neal was able to say. He made references to some of the complex systems we have, and at Kessel Run, we are primarily associated with the Air and Space Operations Center in developing the air tasking order for the Joint Force Air Component Commander. Our AOC, Air and Space Operations Center, is considered itself a weapons system, which is a unique perspective that we have. And as we do the transformation into providing those applications as a SaaS offering, we have different requirements and a different threat landscape than a lot of the commercial analogies that we try and bring into the Air Force. So one is commercial risk exposure is essentially different. We're looking less at criminality or the occasional rogue state actor opportunistically attacking the organization, and more looking at when it's most critical for us to be up and running, we know there will be a state actor trying to come after us. So our risk posture and our risk exposure is fundamentally different, but we still need to be able to take those practices that have been matured through commercial SaaS and bring those into the way we do work. But because of that, it's clear we're in uncharted water, right? Like no one has done this journey before, where there are significant weapon system software as a service being delivered that there isn't a direct analog in the commercial sector that we can follow. So we've come on quite a journey. I would say when we stood up, we had a clear mandate to be agile and to question the way things were being done within the DoD. And largely we were measured on how fast we were delivering. And that's where our focus was on building and delivering the software very quickly. But that probably came at the expense of having as much focus on the security as we needed to have. We had a external pen test conducted and found out that there were pretty significant gaps in where our posture was at the time, and we used that as an impetus to build quite a bit more focus on how we move from just DevOps to what now is within the Air Force called DevSecOps, where security is built into your DevOps practices. So that was a really good experience and allowed us to have the correct focus in how we pulled that together. Where we are now, though, is having that same velocity, but because we're building security directly into our pipelines and our practices, we can have that higher level of security without having to sacrifice on the speed. And that's one thing I would love to highlight is if you have your practices built well, there is no trade-off between being more secure or being able to deploy more quickly. And I think that's something that we've learned over time. And what's made that possible is we have what's called a continuous ATO. So rather than the traditional practices of getting an authority to operate by doing a bunch of security controls and processes, and you get signed off at one point in time, and it's good for a set period of time, and then you go through a review again. We have quarterly reviews with our authorizing official where we do a risk assessment based on how we are conducting our security practices, with the goal being, as he likes to say, being more secure today than yesterday and more secure tomorrow than today. It's built into the way that our authority to operate works, that we have not only continuous integration and continuous delivery, but continuous security improvement. So that is another way that we build security into our basic way of operating. The relationship we've had with our authorizing official has been really just a tremendous one. And over the last year in particular, since I've been in command, I've noticed that mature and become more collaborative as well. One of the things that we do is have assessors come in and have them work with our team to understand where the risks are in our process. We also have a pen test strategy that looks to continually learn by testing different parts of our boundary, but then when we have findings, not just remediating the findings, but create automatic testing where we can continue to pen test ourselves through the way we test and operate our system, and not only have these episodic assessments that are done externally. And we build that in and as part of our authorizing official review. We also make continuous reevaluations of our tool set and our practices, where if a tool set is no longer the right one to meet the threats of the day, we quickly pivot, change to the new tool set that adds the security benefits that we want to have. In that idea of continuously questioning the assumptions, like we're as secure as we're going to get, always testing that and seeing if there's a way to make improvement is part of our overall culture and spills over directly into our security posture as well. We have so one example that may highlight that is so our source code scanners, our CASB and MDM, we've modified those and what our tool set are for those based on where things are moving. So SASE, our secure access service edge, what used to be more familiar as a cloud access security broker. That is the way that we check what's happening at the edge and what's coming in and out. We found that there was a better tool that we could use, went through a big review, and were able to roll that out to all of our machines very quickly and work with our security team to understand what that looked like implications for our dev experience and be able to pull those together. That all comes through because of great partnerships we've had. We've worked very closely with Defense Digital Service, both in terms of understanding the threat landscape, but some tools that are out there. So we've had a partnership with them on a tool that does a scan of public repos looking for code spill, which has been a really interesting partnership and a good one, fruitful in that one. And then working with Neal's group and the other intelligence services on understanding the threat landscape and what tools are out there. That's been extremely helpful for us to stay at that edge. We talk about some of our adversarial assessments. One of the things that we've run into is that our pen test teams, especially within the DoD, don't have the experience base working in cloud environments. So at times we've used those to actually build the skills in our pen test partners and make them more effective as they go forward. So like there's a balance that we use for internal pen testing, as well as doing things like bug bounties, where we can go outside of the DoD where there is more cloud specific experience and make sure that we're augmenting our pen test strategy so that we're getting the most useful results out of those. It all comes down to making sure we're continually more secure than we were before. And we use a framework of making sure that our controls are correct, that we have the right processes, but ultimately that our people are in place that know how to use those. The best tools in the world don't do anything if they're misconfigured. The best alarms in the world don't work if no one's there to respond or don't know what to do when an alarm goes off. So we really mirror up our processes and our controls with our people so that we can use monitoring to identify things that are anomalous, and then have the people with the correct skills and training and experience to go figure out what's happening when those alarms come out. It allows us to be more productive with our staff because we can have them focused on the unusual events and use automation to help respond and monitor where it's more of a steady state. We set the alerts for things that we want to be alerted on. Like you hear a lot about the 2 a.m. wake up call. Hopefully you have your threshold set right, so you're not being woken up at every 2 a.m., but that you don't sleep through things that you should be responding to as well. And ultimately, that means that our people have the right training to know our tools, to understand the continuing evolving threat landscape and how to evolve over time. Some of the DoD training doesn't directly apply to where we are, so we sometimes have to supplement by having folks go out and find the commercial training needed to fill in those skill gaps, given our different posture than a traditional software dev organization. All of this allows us to move fast, to be agile and move at the speed of expectations that people have for Kessel Run. We continuously update our tools. We're never satisfied with being good enough. And over time, our adversarial assessments or pen test results have shown that to be true, and that we continually are building. So even if the first ones showed that we had a lot of learning to do, I think I'm most proud that we've demonstrated that we can take that feedback and build it in and build a more secure platform over time, but never rest on our laurels and continue to push the edge further on what a secure software factory and DevSecOps unit would look like. Thank you again for having me in here. I really look forward to the Q&A so that we can maybe go a little bit more in depth on some of those topics.
Great, thank you, Brian. And now we'll move to our final panelist, Bill Shirles. Bill assumed the role of Office Director for Darpa's Information Innovation Office in September 2019. Prior to joining Darpa from Carnegie, Bill joined Darpa from Carnegie Mellon University. There he served as a professor of computer science, but also as the director of Carnegie Mellon University's Institute for Software Research. During the 2012-2013 time period, he was also acting Chief Technology Officer for the Software Engineering Institute. This is actually Bill's second tenure at DARPA. Early in his career, Bill served as a program manager and later in the senior executive service at DARPA, developing programs in areas such as software technology, computer security, and information infrastructure. And lastly, Bill has led multiple national studies, including the National Research Council Study Committee that produced the report Critical Code Software Producibility for Defense in 2010. And so with that, Bill, we'll turn it over to you.
Thanks, Brad. I'm glad to be here and to give some DARPA perspective. This theme of developing secure systems is really now critical for everyone. And as both Neal and Brian have pointed out, our adversaries are sophisticated, but they're also nimble. The tools of the trade are available, low barrier to entry. So major attacks are now more prevalent. The analysis of SolarWinds, some of the analysts suggested that large teams, careful engineering, they have their own supply chains and a diverse, very diverse set of targets. And we know all this. But we also know that the complex supply chains that we have for our integrated systems make all this harder. And really, SolarWinds reminds us of the leverage to attackers in these supply chain attacks. You know, they got so deep into the build that the malware was actually part of the signed distribution. And of course, that's a reminder that signatures are a signal of authenticity, but they're not a signal of quality necessarily. So I just want to mention a contrast, which is that firms that have primarily organic engineering shops, which is to say a bias to build rather than buy, gain this benefit of a full transparency of all the internal system elements. And so they get an opportunity to manage their entire code base and to develop evidence to support quality arguments about that code base. And one example is the Google repository. There's a great video from about 5 years ago, 2015, late 2015. And there's some features there that are worth noting. Consistent unit testing, program analysis is pervasive, semantically informed fuzzing, architectural control, and architectural evolution. That is to say, constant refactoring of APIs, tightening of APIs, mitigation of internal attack surfaces, configuration integrity management. There are a lot of features here. We still have the challenges of side channels and weird machines, but we also have a better opportunity with this transparency to constrain where we need to cast our human gaze to undertake inspections and to localize difficult areas. So let's now compare this with integrated systems, what Neal was calling composites, which is the reality for many of our mission systems in government and certainly in defense. We have system elements from all over. These supply chains include components and services, but also the tooling, and the tools have their own supply chains. And then, of course, there's the operational infrastructure, which, of course, as we know, includes update servers. Many of these components, as we know, are opaque or unavailable for direct evaluation. That's a kind of a feature of current business norms. So in these circumstances, we really have to trust the supplier, and we mitigate risk through sort of external means, encapsulation, various architectural tricks. So this is kind of a preamble to a set of 7 slogans. I'm just going to put out 7 slogans regarding the development of these integrated systems with rich supply chains. And I'm doing this because, you know, it's easy to say, well, you know, the organic SaaS developers have really terrific tooling and practices, and the government should just follow their lead. And that's a recommendation that's been made quite often over the last, say, 20 years. But the reality is that with our systems integration and our long life cycles, and the diverse sourcing, we kind of don't get to transport those ideas so easily. So slogan number one, know what's there. Map the supply chain, do it recursively. You know that common components may add risk. If you hit walls in the mapping, then you are creating a kind of a trust assumption or a contingency in your reckoning. Note that. Okay, slogan two, check that what's there is what you expect. Okay, this is where signing, root of trust, other integrity checks have value, and recognizing that signing is not a substitute for quality, but at least you know that what you get is what was evaluated. Slogan three, create evidence to support direct technical evaluation. The point here is to replace the historical regime of process compliance. The joke is, am I wearing the right clothing while I'm writing the code? All right. This is an idea that came from industrial statistical process control, which was ported over into the world of software. It's a nice metaphor. It helps us in many ways, but it does not actually grant us high levels of quality and security. So we really have to look at direct evidence derived from the artifacts, and we have to push this capability. I'm coming from Darpa, we're always pushing the capability to drive up scalability, affordability, usability, expand the envelope. Attestation may come from third parties as a way to protect intellectual property, but one way or another, that evidence has to be created and evaluated. Okay, slogan four, build and evolve that evidence in parallel with building and evolving the artifacts. Okay, and this means adapting engineering choices, architectural design features, component selection, and the like, and the tooling to support this. Brian described this as continuous ATO. This is a really, really important goal for us in the DoD because we have to be able to get out ahead of nimble adversaries. We have to be able to exploit the extremely rapid emergence of new capabilities. We have to build these into our systems and continually evolve those systems in not just in response to those threats, but in anticipation. So we have to become more nimble as we go. So an important goal here is to incrementally replace trust assumptions with trustworthiness based on evidence. This is how we can get continuous recertification. So if you're hiring a third party to do an evaluation, in many regimes right now, the third party will spend months and months reverse engineering the system that you built and then check the integrity of the ensemble of the evidence and the artifact. Well, if you're building the evidence alongside with the system, then the role of this third party becomes much more straightforward, and then you can get to that continuous ATO. And by the way, I want to say, security people always disparage bolt-on security, but like it or not, we have to be good at it because we have so much of a legacy, and we are really focusing on how to do that well, how to do program understanding to create evidence, but then how to capture that evidence in models, retain it, build it into the iterative process. So we kind of encroach on the dark shadows of the legacy. You're all familiar with legacy artifacts that are surrounded by superstition because we are fearful of tampering with them in any way because we don't actually know exactly what all the design assumptions are. Okay, 3 more slogans. Slogan number 5, know what's contingent. If you're an integrator, know what your trust assumptions are. What are the boundaries between what's trustworthy based on evidence and what's trusted because you don't know enough to create evidence? And then minimize and localize what you need to trust. Slogan number 6, make all this as usable and scalable as possible. So this brings to mind formal methods. Everybody's been talking about formal methods. We've been thinking about formal methods at Darpa for coming up on 50 years. But modern formal methods are different from the old ideas. Hide the math, make it composable. Type systems in programming languages are a great example. Since Nick is here, Microsoft's IL, the whole ensemble of .NET has type integrity built into it. It's invisible to developers. That's the ultimate usability. At the FM89 conference, We said small theorems about big programs, because what we had at the time were really big theorems about always very small programs. So we now see this scalability as emerging. It's real. It's happening. Some of those organic shops I mentioned are doing it in very good ways. But you're going to have always informal and formal, many kinds of models. This was also pointed out by Neal that there are many kinds of attributes that we care about. We have to have arrays of models for all of those. And we will also always have trust assumptions. We need to know what they are, because those are the places where the side channels are lurking. Slogan number 7, frame all this with the basics. Let's go back to assessing cyber risk. Let's go back to talking about attack surface. So cyber risk is about threat, consequence, and vulnerability. Threat and consequence, as Brian pointed out, are extrinsic to the system. We have to do threat assessments. It's not about the system, it's about the environment in which the system is built and operated. Vulnerability, though, is a characteristic of the system. None of these are stochastic. Those old Bayesian actuarial risk models that insurers use, they don't apply here. But we have to build these models anyway. And then there's attack surface. Has this been forgotten? Attack surface is where threat meets vulnerability. The key point with regard to supply chains is we have internal attack surfaces and they go both ways. And so when people talk about zero trust, so-called zero trust architectures, encapsulation, sandboxing, monitoring, logging, measurement, all of this has to do with managing these attack surfaces. Okay, and so those are the 7 slogans. I've got a bonus slogan because I have to give you slogan number 8, the bonus. Keep pushing the technologies of assurance and security, because there's no plateau. We're nowhere close. Everything is moving very swiftly. What Brian said about the need to keep getting more secure, it's really important because the adversaries are getting more capable. And so we're constantly looking at new ideas and new technologies. For example, just to pick something random, secure multi-party protocols is a way to reduce the need for trust. So the ensemble becomes more trustworthy, even if the components are not trusted. So any tooling framework has to be able to continually add new capabilities. I'm also repeating a comment that Brian made. So that is that's my introductory remark. Thank you very much.
Okay, great, Bill. Thank you very much. And again, I'm thankful for Neal, Brian, and Bill for your introductory remarks. And so what we'll do now is sort of open it up to questions. Participants can place questions into the chat, and we'll select from the chat for the panelists. I guess maybe I can just start things off. So we heard a bit about supply chain from the panelists. And so, Bill, you also mentioned sort of the nature of sort of the opaqueness. And so, but there's also sort of a range there, maybe from opaqueness to open source systems and platforms. So can you maybe talk a little bit about that sort of the range and the impact of sort of that in regard to the role of supply chains in thinking about development of secure systems?
Yeah, sure. It's I think that this is a very key point, Brad, and I'm glad you raise it. It's not all or nothing with respect to transparency and access. And in fact, there are a lot of ideas that are being explored about how to share some features, some elements of the design without sharing everything. So that way, for example, we can have a group of competitor firms collaborating on a shared integration framework, but competing on providing the component capabilities within that framework. This is an idea that's actually being tested in some acquisition shops in the military. There's a framing called an associate contractor agreement, ACA, that allows a kind of a degree of permeability of this with respect to this opacity, so that a group of firms can collaborate with each other and with a program office to develop a design for integrating capabilities of framework design, and also continually evolve that design, just the way your mobile app frameworks continue to evolve. Even though they have more than 1 million apps in each of the app stores, everything somehow flies in formation. The network externalities, the incentives are all aligned in a good way. So there's experiments that are going on that are testing these ideas, where we share enough that we can have that commonality. Maybe we can also think about how to share enough that we can make a claim for trustworthiness with respect to certain of the critical security criteria, but we can do that in a way where the core IP that creates competitive advantage for a firm does not itself have to be compromised. And so this can be done through a variety of means, partly third parties, partly technical mitigations. I think this is something that is a really significant topic for us to explore to get us away from the complete stonewall of full opacity, which is sometimes now a feature. It doesn't have to be a feature, and we see a lot of cases, for example, where firms will, as a deliberate choice, put components and capabilities out into the open source world, and even fund those because that's viewed as beneficial to their business model.
Okay, great. I'd open it up to Neal or Brian. Any comments?
I'd like to jump in briefly, Brad. This is Neal. I love that notion about opacity, transparency being a bit more of a dial than a on-off switch. I think that goes both ways. In many cases, a government can be more transparent about the environment into which some of these systems will have to integrate. Many systems today, in my experience, end up taking on responsibilities that would be better provided by an enterprise service or a shared or common framework. But because the person building that service cannot know about that or is not allowed to know about that, then it doesn't get used. And then you get the stovepiping where, certain functions are implemented a dozen times across a dozen systems. At NSA, we're trying to do a better job with that by exposing how we do, for example, internal authorization, permission type functions, so that folks who are building systems for us can integrate to that and not have to try to build it themselves, only to have us later rip it out and replace it with the enterprise solution when it gets into our enterprise. I think that the same is true in cloud environments, but I'll let the kernel talk about that part. Over.
So one of the things that we try and do is, where possible, if we're going to host the software ourselves, we try and get, I guess in this framework it would be the most transparent, but even like the open source code where we can push it through our scanners and understand exactly what's there. But there are other ways that we can also consume software as well. It just means we have to build it within that risk framework to understand if we're unable to have full transparency, what does that mean in terms of how we operate the system, so that we know how to allocate maybe monitoring, or how do we put controls around it, so if there is a risk associated with it, we can mitigate that risk or draw attention to it so it's monitored a little bit more closely. So there's more you can do in how you implement those solutions that can be tailored to exactly what you know about the system and how transparent there is. So I agree. It's less of a binary and more of how does it fit within, and where do you pull it into your overall risk management process. Not the whole RMF stack. Like I don't want to go back to that world, but actual risk management.
Okay, great, thank you. So we have a couple questions in the chat, and so maybe since Bill had brought up attack surface, maybe we'll let him sort of begin on the first one. Says, could you comment on game theoretic approaches to dealing with system vulnerabilities by evaluating which mitigation actions reduce attack surface better than others? And again, Bill or others, would you like to jump in on that?
So I'm going to make some guesses here. If you think about attack surfaces as where threat meets vulnerability, the game theoretic aspect, I'm just maybe some clarity from the questioner would be helpful, but I could guess that the game theoretic aspect would relate to the interplay of our understanding of the threat model for the particular context of use of a system, and our understanding of vulnerabilities in a system, and how we can set priorities, for example, regarding where we should focus our attention. Because this is always the challenge when we have many findings from analyses. How do we set priorities? Well, we're going to set priorities based on understanding of the threat and understanding of consequence, those extrinsic factors, as well as internal, and then the range of mitigations. We have quite a range of possible mitigations, including just constraining the attack surface as a matter of engineering choice, but we can also have other kinds of mitigations. So maybe that's not a very useful answer, but I'll let Neal and Brian have a shot at it.
And Bill, it seems like you sort of hit on the game theoretic modeling of threat modeling and risk assessment, which was the intent of the question. So Neal, we'll give it to you.
Okay, so I'm going to push back a little bit at the questioner. I've been involved in a number of sort of gaming model risk analyses and such over the years, and to some extent I've found that they're very difficult to get useful or actionable answers out of. And so we're really pushing more towards trying to use what we understand about adversaries and their tradecraft to do more threat-driven approaches to system vulnerability, right? If we have a great deal of evidence that threat actors like to go after, for example, the interface between on-prem systems and cloud-hosted systems, then that tells us to spend extra effort on those interfaces. And, you know, I think there is a place for sort of more abstract approaches to help us understand where we should invest our efforts, because we never have effort to spend equally across and infinitely across a whole system. But I view those as secondary and threat-driven as primary. Over.
Okay. Brian, any thoughts on this topic?
So I think the only thing I would add into it is one of the approaches that we use around the monitoring and having telemetry and in knowing your system is at some point you don't know where the attack surface that will be exploited is going to be. So understanding your own normal behavior and being able to identify quickly anomalous behavior and to be able to respond where it is important. I don't think anyone thinks that they can 100% defend all of their attack surface. So rather than concentrating forces where you think or concentrating attention where you think it's likely to come in and you could be wrong, you need to have that defense in depth, assuming that there may be an opportunity where someone gets through, but be able to identify what happens in that event and be able to remediate it more quickly.
Can I just add one point to that, Brad? Just to reinforce what Brian just said, that there's huge value in monitoring and telemetry, and you know it's creates enormous oceans of data. But we have to figure out what data to retain and what data can age. One of the interesting features of the SolarWinds was once it arrived at its destination, it sat quietly for 2 weeks. Well, that's because log data would roll out after 2 weeks in many places. And so when it finally woke up and started to beacon, there was no longer any trace in the logs of its arrival. Interesting, right? And so we have to think really in a clever way about the nature of the monitoring and the logging and what kinds of data we capture. But we also have to think carefully about what's normal and what's anomalous, because when your sysadmin comes to visit you in your office to fix what's ailing you at the moment, everything they do is kind of anomalous, right? And so you have to capture all that because we know there's some well-known incidents where that was exactly the attack vector. So figuring out how to do the right kind of logging where we really capture the full scope is essential. Over.
Neal, did you have another comment?
Mute button. Yeah, I just want to add briefly to something that Bill said. And back to one of your slogans, Bill, I think it was either number 1 or number 3, about evidence, right? If we're going to continue to depend on large amounts of software components that we get from third parties in all sorts of fashions, it would be really cool if they could bring with them as part of their evidence some notion of what normal is for them, right? People didn't catch SolarWinds because it was sending DNS requests out to a DNS name that looked sort of superficially normal, right? But the SolarWinds engineers knew it wasn't supposed to talk to that domain, but they had no way to communicate that to the thousands of customers who then ended up beaconing out to this domain. So in addition to things like software bill of materials, I'm going to propose, and you can use this name freely, SBOB, Software Bill of Behavior. What is the normal behavior that you can expect from this software at a high level, so that you can kind of plug that in to your threat monitoring and say, well, if it's doing other than that, it's doing something that the maker did not expect. Therefore, I need to investigate more closely. Just a thought.
Okay, and Bill?
I just want to endorse Neal's idea. I think it's a terrific idea that, at Darpa we have a number of programs that are involved in kind of doing analysis of these oceans of log data, and trying to find interesting features within those. And the challenge is always sort of what's anomalous and what's not. And the idea of SBOB, which says, here are the communication pathways that are in scope and nothing else is in scope. That's really important. I just want to note, that in SolarWinds, an interesting feature was they had US domiciled command and control sites, because that would thwart, for example, Neal's immediate colleagues from engagement because of the authorities that they have versus, say, the law enforcement authorities. So these guys are very savvy about their notion of what's their threat landscape, right? The counter threat landscape and how we operate. That was wired into their engineering.
Okay, great. Let's move on to Daniel's question regarding side channels. He says, can the panelists comment on where they see opportunities for side channel research that is DoD relevant? Anybody want to pick that up?
I'll start with that. I don't mind. So one way to think about what we do in engineering is we build models. Models are imperfect, approximate representations of whatever reality we happen to care about. And then we reason within those models. It's like doing math. We manipulate symbols. And then on the basis of that symbol manipulation, we make predictions, hopefully, regarding the reality, the underlying reality. And so good models are predictive and bad models are not predictive. But worthy models model salient bits of reality and ignore other things, and so on. So we could say that as we do engineering, we're modeling performance, we're modeling all the various security attributes, we're modeling, resource usage, all kinds of things. And then the question is, well, what's a side channel? And you could argue that the side channel is what you haven't modeled, right? And it's what when the adversary comes in and says, we've got, and this is open literature published 15 years ago, an example, which is we've modeled the math. Our crypto algorithm has absolutely beautiful, wonderful math, and we've built models of that math, and we've proved a lot of theorems, and we know it's good with respect to various goodness criteria for crypto. But what we did not model was the electrical activities of the chip that's executing the algorithm, right? And so that was not modeled. Maybe it was or was not anticipated, but because it wasn't modeled, we deemed that it's a side channel when we're making use of electrical characteristics to actually discover keys and the like, right? And so that's kind of a canonical example of a side channel. But generally speaking, what you haven't modeled is an area where you have trust assumptions of a certain kind, And so if you're thinking about things comprehensively, well, there's some things we know how to model and other things we really kind of don't know how to model. Well, then those areas we need to figure out how to pay attention at least.
Okay. Neal or Brian, any comments? Okay.
Okay, I was going to let Brian jump in. I'll just do one small one, Brad. I think that there's been wonderful side channel research in the last few years about what I might call typical or traditional side channel targets. And it's expanded, right? Some wonderful research in the last few years on processor side channels and Spectre Meltdown and all the things that came after them. What I think we haven't done much yet are side channels that are evidenced from systems in the large. And in DoD, I think we're very worried about this because we will have systems where some of their communication paths are open to inspection by an adversary, or at least monitoring by an adversary, and some of their interactions are not. And I find myself wondering, for those interactions that are observable by an adversary, what do they give away? Of, say, a large system like JADC2 or other global command and control system. What are they giving away? Over.
The idea that side channel is anything we don't model, I love that as a concept. And what it makes me think about is testing those assumptions, right? Like, and as we move to SaaS offerings, the idea that things that were assumed not readable by an adversary in the past, we need to question those assumptions. And where we have assumptions built in, we're probably not modeling it because it's one of our assumptions that go into the process. So I think this goes to the need as we move forward to question the assumptions, continuously wonder what is it that we're assuming exists because that's the way it's been done in the past. And not just do the same thing in a new way, but think about what are our basic assumptions that have led us to have our posture, and how do we question those for tomorrow?
Okay, great. Bill?
I just have one more point I want to make about this, which is, when we talk about side channels, we should also talk about a concept that some people call weird machines, right? Which are execution modalities that are afforded through broken abstractions, right? And so you can think about a lot of what we do as, if we think about the semantical building blocks of software as these abstractions, symbolic representations within the system, then the defender's job is to protect abstractions, protect their integrity. C versus, say, C#, since, again, Microsoft example, C# will maintain the integrity of your representation of an array, for example, whereas C lets you do arbitrary arithmetic within the heap, and so all bets are off. And so the idea is for the defender to protect the abstraction. The attacker wants to break the abstraction. That's what a buffer overflow is to break the assumptions that we have about the relationship between the abstraction and how it gets represented. So just a way to think about things. Over.
Great.
Yeah, that kind of brings us to one of the other questions in the chat, Brad. Do you want to jump to it? The one about programming languages?
Oh, sure. I was going to move to open source, but I can.
Oh, sorry. That's a good one too. Whatever. You're the moderator.
No. We can get to that. Here, let me bring that up. This is from our host here. Can you comment on the prospects for adoption of new, safer programming languages in the critical systems that you build? I'm thinking in particular of how you think to balance the adoption of new technologies versus what I may incorrectly perceive as the government's need to maintain an interface with legacy systems built several software generations ago. So, Neal, do you want to pick that up?
Yeah, I love that question. So thank you, Nick. I think there are great prospects for that, and in two particular areas. The first is what I might call safer or somewhat more in abstraction protecting general purpose languages. C#, a good example, various Java variants, and sort of the 600-pound gorilla in that space at this point might be Rust. Wonderful language that protects its abstractions with a fierceness that I had never before encountered before attempting to learn it. And then the other side of it, I think, are languages or systems that give you an abstraction that is particularly good for certain types of coding. And my favorite example here, Brad, is a system that you worked on for a long time, Cryptol, where it has certain abstractions that are excellent for doing cryptographic computations, and the coding guides you into sustaining and maintaining those abstractions. And so I think both of those are very worthwhile, but they'll get more traction if the folks who offer them can offer abstraction-safe ways to interface to the outside world. And I think both C# and Rust have some interesting lessons to give us there. Over.
Bill, Brian?
Brian, you want to go?
Yeah, let me just jump in real quick. One of the things that I would want to touch on with this is pivoting a little bit off of the particular language and have it be about interoperability with legacy systems as a whole is one of the things that I deal with on a daily basis. As we do the modernization of the AOC from standalone applications that are working on an on-prem server stack to moving to SaaS offerings. One of the things that we've had to do because of that is how do you isolate the old systems so that you can then translate it in? So we build a lot of anti-corruption layers to be able to interact with legacy systems and not have a hard integration with those systems so that you don't have to continually to be dependent on those legacy things. But more importantly is how do we make sure that as we do a modernization, we're not creating the next COBOL where we can't move off of that and we create our own diminishing the supply of folks who can work in that language. Even in the time that Kessel Run has been here, we're looking at making a platform transformation as well and moving to Kubernetes, and that takes a lot of work to be able to get the workforce to move to that. But it's incredibly important because if you make that decision early that you're not going to keep pace with a changing landscape, you will never make that decision. If you don't make it the first time it comes up and you say, we're going to defer that decision, you will always defer that decision until you're no longer relevant. So I think it's really important to embrace the changes and make those moves, because if you get in a pattern of habit of not doing it, you'll never get out of that cycle.
So at the risk of being boring, I'm going to completely wholeheartedly endorse what both Neal and Brian just said, but I just want to add one more thing, which is people say, well, you know, if you're going to make things more secure, then you're going to make an investment. And the old story is there's a big breach, and so the CTO goes to the CEO and says, I need $2 million to enhance the security of our systems. And the CEO says, well, whatever it takes, you got it. And so investments are made, and then 6 months later, the CFO team shows up at the doorstep of the CTO and says, we just gave you $2 million to do this security enhancement. What's your return on that investment? And how do you answer that question other than saying, oh, $2 million worth of security, right? and so the point is, if you want to make an ROI case, you've got to have a way to measure the R. And so this is, for us, it's an enormous research challenge. But all is not lost, because there's another angle on this. And the angle is that, well, we could also just provide security enhancements while at the same time making life easier and more productive for developers. And so Cryptol is a terrific example of that. It's absolutely a beautiful language. If you're not familiar with it, you can download it and play with it. It's really wonderful. But also there's TypeScript, which is now used by the majority of JavaScript developers. And they're not out there to make things necessarily more secure. The languages like C# and Java and others, these have positive productivity benefits. The tooling is such that you catch things earlier, more things earlier in the process. So you're moving to the left, which is always what you want to do with these improvements. So measurement is the big challenge. It's also highly dimensional. It's not like, well, how secure is your system? There are many, many attributes, and it's a complex calculation. But one of the reasons why, I can't remember which of the slogans, I gave the slogan of going back to basics is we always have to struggle with the measurement challenge. Even if we're not going to get it right, we still have to come up with metrics, and we keep having to keep evolving and adapting our metrics so we can see the benefits. But if you're in the business of helping make things more secure, figure out a way to also make your developers more productive at the same time. Because if you don't do that, then, and if you don't have the ROI case, then you get something I've been calling MVS. We have, you know about MVP, right? Minimum viable product. You get minimum viable security, which is just enough security not to embarrass yourself, regardless of what awful things might happen later. And that's what you get out of the gate. So that's where we want to escape from. Over.
Right. Let's pick up that open source question by Alexei. He says, using open source software creates an asymmetry. It's easy for the adversary to see the packages included in a system and to test attacks extensively. Limiting the use of open source software seems counterproductive, but how do you feel we should address the asymmetry from the growing use of open source software? Anyone have thoughts there?
I'll defer to Brian to go first.
So I think what we believe, or at least our strategy is, with the open source, it allows an ability to continually get the updates over time and bring that in and to understand. The risk is that there is a unidentified 0-day that's part of that open source project, but at least the theory is that people will find that and be motivated to fix it and address it, or if we can bring it in, we can potentially identify and fix those. So I actually think the risk of there being an unknown exploit that's coming out of an open source project is smaller than what I've seen in practice in other realms. So there are some software that I have to use as a reservist that, because change is scary to people, and this is not a tech thing, this is like a human emotional response, that I believe change to be more risky than staying with what I'm on. So what I've seen in the past is, rather than update and address things, they said, well, I used it yesterday, it must be secure, I'll use it tomorrow. And they actually prohibit changing systems to the point where there are some applications that we have to use, and you have to use Microsoft IE in compatibility mode, otherwise it won't work. And it's no dig on any particular browser. It's like the dig is on the mentality that says we're more secure by using a legacy deprecated browser that it was configured for than to modernize the underlying software. So I think one of the things that I like about open source is it kind of takes that decision to move away from you, because it is continuously being updated and evolving over time, because I've seen it work the other way. So that risk that you get with the open source is balanced by the apprehension people have for making changes from something that was in use today.
Hey, Brad, this is Neal. I agree with what Brian had to say. I'm going to add something a little bit different. First of all, I'm not sure that asymmetry is as great today as it was, say, 10 or 15 years ago. Reverse engineering of software has gotten a lot better. A lot of systems, I mean, one of the trade-offs of going to these safer languages is that they're also easier to reverse engineer, because there's so much more information there for a tool to grab onto. So the asymmetry is not perhaps as great as it was. My bigger concern with open source is more of an environmental or community-driven thing. The way the open source culture seems to work these days is never build something if you could consume it from someone else as a dependency. And there are a number of commercial products that will help you track those dependencies. And I think in many cases, it's a good idea to use those products. But their results are shocking. Something you might characterize as a medium-sized open source package might have between 400 and 1,000 dependencies. What? So, and tracking that can be insanely difficult, and it opens up your supply chain to a very wide aperture. So I think open source is great. We use plenty of it. Lots of DoD uses it. It just requires maybe a bit more care or visibility. And this goes back to Bill's slogan number 1, know what's there, right? And if you can't do that with that particular open source package, maybe that's an open source package you should avoid.
Excellent.
So I just want to add a little bit to this, if I could, Brad. So the equities are complex. It used to be there were big arguments, in government. Oh, should we use open source? Should we not use open source? And there were strong advocates, and then strong detractors. And I agree with Neal that there's kind of a narrowing of the gap, that the equities are complex, and there's no pat answer. So on the favorable side, you get full transparency, but you also get the ability to participate because the successful projects really operate like consortia. It's economically, that's the economic model. Whether it's actually concretely implemented that way or not is not the point, but that's the participation. You get to fix bugs, you get to add features. If you develop trust relationships, then your participation can increase, so you can put the test cases in that you need, whatever you want. Whereas with respect to vendor code, the argument goes, our adversaries know more about the vendor code than the integrators, our own integrators do, right? Because they have these wonderful reverse engineering tools that Neal just described, right? And so also on the plus side with open source is we can overlay evidence, because all the data management, the engineering data management, that ultra granular, every single line of code, we know the provenance of it, who did it, why they did it. That's why that Google repo video is so good to watch. You get a sense of that. Or just go visit an open source major site and you can look right in and watch the development in action and see how everything connects. The formal method stacks, most of those are open source. So, but on the other hand, on the negative side, there are interesting social engineering attacks that are happening in open source projects, right? It's open participation. You say, well, there are all these hundreds of developers that are participating. It's still only a handful who are the primary committers, but there are many others who may put in things that look a little buggy, but those bugs are actually backdoors, blah, blah, blah. There are grumpiness attacks where open source developers, not the ones who are having an economically successful model, but those who are kind of servicing hundreds of thousands of users and not getting any compensation for that, get grumpy and tweak things. But then there are also neutral elements, which is the update path for open source. It's similar to vendor code. And in fact, one of the things that happened in the history of Linux was with Red Hat and others was the creation of releases that were more enterprise friendly than they had historically been in the Linux world, less frequent, more testing. There were the enterprise friendly releases, whereas other developers were getting more frequent releases, maybe not as hardened. So the one last thing I want to say is if you look at the model of GitHub, GitHub has a very interesting reinforcement model with these very rich supply chains that Neal just noted, right? Because it actually has a kind of positive externalities, this reinforcement scheme, whereby if you're a GitHub participant and you get credits and you get pull requests and you get all these various kinds of badges of honor, because people are using your stuff and you're using their stuff, that interdependency, it's a lot like social media. It really works. Over.
Okay, thank you, Bill. So let's go to Brad's question. This is probably most focused on Brian. So it says, when developing a centralized software repository such as Kessel Run and Platform One, is there a trade-off to looking at vulnerability penetration testing and monitoring versus building in resilience, diversity, and assurance into the software build? How do you balance these two sides? So Brian, do you want to pick that up?
It's a great question. So in addition, to having our SecRel pipelines do all the scanning and testing as it goes out, we have taken a focus on building security and secure practices into the way we do our own development work. Over the summer, we had a special team look at well-architected apps and in putting out best practices for how app development should happen to build security into the system and to have that be part of our dev team's professional development as we go forward. We've also seen a massive shift over the last 12 months on the security consciousness of our dev team in asking questions as opposed to assuming answers. We talk about that a lot. Like, I'd rather have someone ask a question that they should know the answer to than assume they know an answer and have that answer be wrong. So we've done a lot of work to lower the risk associated with asking questions around what is the right way to handle things, what is the right design structure for how to build out the dev work, as well as having a collection of best practices to build security into our system. So much of what I talk about, our AO talks about processes, controls, and people. So much of what we focus on is the people aspect of it, because if it is our people doing that, the development team work, they need to understand the implications of how they do things. They need to understand if they take a shortcut to deliver faster, what that means in terms of the vulnerability of the weapon system. What's incredibly important is because what my very first sentence was when I gave the overview, we are a weapon system that we know will be under attack in time of war. That is, there is a necessary part to build that in, but there is this also attention that you won't actually be truly tested until it really matters, that we have to have that built into the way our teams think about the importance of what they do how they do their work. So we take a full breadth approach to it, from the way our people design the architecture of the applications, to how we store and share our code, to how we do our SecRel pipelines, and how then we monitor and do pen testing of it in practice in production. So all of that matters, and you need to have that entire build release process monitored and look at improving on the whole thing. Focusing on one aspect and letting others go with less review is never going to be a successful way to build security in.
Okay, great. Thank you, Brian. Let's go to Jeremy's question. So he talks about the challenge of sort of the market for lemons, and so the question is, how can we provide useful signals to non-experts? It's not price. For example, Einstein missed SolarWinds, which some other systems captured, even though Einstein is more expensive. Anybody want to sort of talk to sort of that perspective of market for lemons?
I'll give that a shot, Brad, and I think Jeremy raises a fair point. Unfortunately, most of the detectors that we encounter today are not even at the level of cars. They're more down at the level of a fuel filter or something. Most of our detectors are detecting and then alerting on very low-level events. And my proposal for solution to that is to raise the level, right? I think it's not quite true that consumers can't tell the difference entirely between a good car and a bad car. If you've driven lots of cars, you get in one that's obviously faulty and it becomes clear to you right away. Can we get detection of anomalies or exposures or attacks up to that level? So I'm not getting a message that says a SAML token was issued that does not match other SAML tokens. And my defender is going, well, what the heck does that mean? Instead, an external party was just given access to all your email. Are you happy with that? That would be a higher level event that my defender might go, no, I don't want that. Let me take immediate action. And so I think that's the answer, is building up our ability and the systems that we build to deliver into higher level events that have mission meaning rather than sort of low level techie meaning. Over.
Okay. Anyone else? Comments?
Yeah, just this is kind of similar to the notion of minimum viable security, which is things regress down to this awful low baseline when you can't measure stuff. And there's a little bit of a sort of a business school case on how Toyota came into the U.S. market on a quality proposition, which is they figured out a way to I don't want to say monetize, but a way to actually sell quality through having a long-term warranty. And so that's the challenge, and that's why I think measurement is our hardest problem. We have all these various kinds of indirect assays, but you can't test quality in, you test bugs out, and that's a long-standing slogan that goes back for years and years and years. And the question then is, well, how do we actually make a positive assessment of the presence of quality? And that's where these newfangled methods are beginning to show themselves, and where I think we've just the way machine learning crossed a threshold about 15 years ago, and it suddenly burst into the zeitgeist, even though, in fact, statistical machine learning as an idea had been around for many, many decades before. I think that we're getting to a point where this notion of positive case for quality based on evidence is really emerging into a mode where it's scalable, affordable, and adoptable by actual developers and evaluators. I think we're getting to that point. So I'm very excited about that possibility, because I think that's a way to get out of this particular bind. Over.
Okay. All right. So we're almost out of time, but I wanted to ask one more question. And so it sort of builds off of, Bill, what you were just sort of closing with there in regard to usability, scalability. Earlier you'd mentioned, I think it was maybe item number 6, and I don't know if we get royalties for mentioning sort of your 7 or 8 sort of ideas here, but I think it was number 6, and it was talking about usability and scalability of formal methods. And so I would sort of be interested to hear sort of Brian's perspective in regard to, because he touched on sort of tool specifics, but on the appetite sort of, say, within Kessel Run for deeper analysis using some of these really sort of emerging formal methods tools, again, which have those sort of attributes of usability and scalability, and really so much so that sort of it maybe is able to leverage into sort of individuals who aren't deep experts sort of in the tools or languages. So could you say a little bit about that?
Speaking of not being deep experts in the tools and languages, I would love to have Brandon Johns, who's my CISO, on here. He's done a lot of the work and could probably talk more about formal methods than I could. I can speak to you. I can definitely speak in terms of the translation piece, specifically the idea of how do you make a technical thing meaningful to someone who doesn't speak technology. I had, so as an example, I do a lot of stakeholder engagement in my position as commander. I went to one stakeholder office and was telling them all about how the tools will be SaaS and they'll be reachable from any standard desktop computer. And the question I got was, well, who comes to my computer and loads the software onto it? And so we're talking about a pretty significant divide at times that we need to bridge. For me, it's talking about it in terms of value. What is the value that person cares deeply about? Is it optionality? Is it security? Is it availability? And being able to take the technical thing that they won't be able to understand and to say, okay, if we can boil it down to an A versus B decision, I know that you care about this value. Here's how the differences between these two will impact your life around that value. And we spent a lot of time having conversations with people about the very specific technical discussions. I tried describing a hybrid cloud architecture to folks and just realized it was way easier to say high availability. If the network drops out, you have a local node that you can still get some of the mission done, right? Like, because what mattered was mission availability. So that's the guiding premise I have, is how do you actually convert the technical discussion into a differential impact on the things that they value the most. And sometimes that means we have to put our technical acumen in the back seat, because where we like to demonstrate value is actually not what matters most to the person we're talking to. But we need to be able to translate that and be right, because you can't simplify things and then be wrong. Otherwise, you won't be believed in the future. So I think it's a hard thing. But if you talk and really understand where your stakeholders are coming from, what they value, and be able to put it in real terms, that's the only thing I've found to be truly successful over time.
Okay, great. Thank you, Brian. And so maybe what we could do is we have maybe 3 minutes left. Maybe we could have a minute from each of our panelists just to give a closing thought. Maybe we'll just go in reverse order. And so, Bill, do you want to start us off with a closing thought for this panel discussion?
Sure, thank you for that. And I just first want to say I really enjoyed this conversation with you, Brad, and Brian and Neal. And Nikhil, I wish you had been able to kind of participate as another panelist, because you guys are doing really interesting things. But what I want to say, though, is my last comment is just on this last point about adopting some of these more advanced techniques. And I think partly what's going to be most successful is what I would call a sneak attack on the transition, which is to build it in to tools that, so that it's the trick is to package revolution as evolution, right? And it's the opposite of laundry detergent, where you add some little blue granules and it's revolutionary and new. You know, our desktop metaphors haven't changed since for 30 years already, and they've become familiar, even though the capabilities behind the curtain have really dramatically changed. So, for example, modern testing and fuzzing tools, the good ones, are actually very deeply semantically informed, using all kinds of analysis techniques. Modern programming languages make hide the math and do lots of very significant things to great benefit. So the point is, we shouldn't think of it as a binary, are we doing it or not, but rather let's figure out what incentives we can create for our tool providers, and the vendors who are providing us with components. For example, can you ask a vendor, say, what are you willing to promise me with recourse, right? Because right now, no recourse, right? What are you willing to promise me with some recourse that goes beyond just the licensing fee? Pick any quality attribute, anything that you can be willing to stand behind. Let's just slightly move very incrementally in that direction, because the moment we have the first example of that, then I think, and we can prove the point, I think we're going to have a lot more. And by the way, can be a positive competitive attribute. It's not just mitigating the downside. It can be a really positive competitive attribute where we can make positive assertions of quality. We have to think about the incentive structure in these supply chains. And that's my final thought. Thank you, Brad.
Okay, thanks, Bill. Brian?
I just want to double down as well and say thank you for having me, and a great conversation. I love to hear it, and glad I was able to play a part in it. The thing that I would want people to take away is all of this has to be done with a sense of humility and a sense that we have it wrong today. We maybe have it as good as we can, but it is still wrong today. The mentality of seeing the results of your own test, to see the results of your own data of what's happening on your network, your own internal scans, and taking it with humility and in actual third eye. You can't, a third person view of it. You can't wrap your own self-worth into the way your system is today, because it always will be wrong today. You have to be purely independent of it and look for ways that you can improve over time. The moment we say we got it right, and you wrap up your value and your self-worth into your system staying as it is the minute you are personally introducing risk into your system. That was our biggest shift, is having to say, we will never get this right. We always have to question. We have to say, where were we wrong now? We have to do pre-mortems. We have to look at our data and understand where we need to improve, and always bring up the level of all the players on our system. So I think that would be my one take if I wanted to summarize. You have to come at it with humility, and you have to come at it with a sense that you are currently not doing it right, because no one knows what right is. But that's not a flaw.
Great, thank you, Brian. And Neal?
Okay, on so many areas that I could hit, but I'm going to stick in my proposed high-level idea that one of the biggest obstacles to secure systems in operation today is exactly what Brian was just saying. It's stasis. So the ultimate goal, I think, for many system developers is design your system so that it can change, so that it can continue to operate through change, so that our defense customers, government customers, et cetera, will be willing to undertake the change that will improve their posture over time. And that touches our languages, our frameworks, our platforms, our methods of distribution. All of those aspects of software would be touched by a greater ability to support and be resilient to change. Over.
Great, thank you, Neal. And so let me just say a few closing words again. So thanks to William and Matt on the Microsoft side for really setting this up for us and enabling us to have this conversation. Really appreciate that. Obviously appreciate Neal, Brian, and Bill, you as panelists, just a terrific dialogue, and also wanted to thank sort of the participants and their questions for motivating sort of a great discussion, and then lastly to Nick, again, thank you for setting up sort of the opportunity for us to have this conversation, and for Microsoft's support of DS3. So with that, I'll turn it back over to you, Nick, maybe for a last word.
Yes, thank you all. That was really inspiring. I've got lots of notes here in my Emacs buffer that I'm stuff for me to chew on. I'm sure others feel the same. Thank you very much, and thank you, Brad, for moderating. That was really great.
Great.
See you in 2 weeks. We have Ashley Williams from the Rust Foundation 2 Wednesdays from now on March 31st. Tell your friends about it, and hope to see you again.
Thank you.
Bye.